Circle. A circle is the locus of a point which moves in a plane such that its distance from a fixed point is constant. So this is the fixed point, and around it a constant distance. Yes, so let me just roughly draw that. Okay, let's say this is the circle. Let's say this is the center. So C H comma K is the center. Remember, we put a coordinate system. R is the radius. P X comma Y, let's say this is P, is an arbitrary point, random point on the circle. So now if you look at this and you look at this, and this is our radius. Let us say this is D. Now CP is the radius. So let us say this is R. Now in triangle CPD, angle D is equal to 90 degree. Angle D is 90 degree. So which means what? By the Pythagoras theorem, CD square plus PD square is equal to R square. CD square plus PD square is equal to R square. Now what is CD? CD is this. Now remember, here C is H comma K. So H, and here it is X. So this distance would be what? X minus H. Similarly, if we look here on the y-axis, this is K and this is Y. So this distance is going to be Y minus K. So CD square is X minus H square plus PD square is equal to Y minus K square equal to R square. This is the equation of a circle. Now if the center of the circle is at origin, then H equal to 0 and K equal to 0, which means X square plus Y square equal to R square. Now let's take particular case. Let's say H is equal to 2, Y is equal to 3. Yes. Then based on the above equation, we will end up with X minus 2 square plus Y minus 3 square is equal to R square. Let's expand this. X square minus 4x plus 4 plus Y square minus 6x plus 9 equal to R square. Okay, X square plus Y square. Now 4x no, this is Y, 6y. Now this can be written as plus 2 minus 2x plus 2 minus 3y plus 13 minus R square equal to 0. Now let us say this is G, let us say this is F, and let us say this is C. Then our equation becomes X square plus Y square plus 2GX plus 2FY plus c equal to 0. So I feel that this represents a circle. Now, is that correct? Let's see whether we can prove that this represents a circle. So x square plus y square. Let's rearrange it. X square 2gx plus y square plus 2fy equal to minus c. Right, and just to make it as a perfect square, let's do one thing. X square plus 2gx, here let's add g square, right, and plus y square plus 2fy, and let's put f square here. So this and this becomes perfect squares equal to minus c. Now, because we added g square and f square, let's add on this side also. Okay, so this becomes x plus g square plus y plus f square is equal to g square plus f square minus c. But what we want x minus h square plus y minus k square is equal to r square. So we can write x minus g square plus y minus f square is equal to, now this also we have to write it in square form. So which means if we make it square, we have to cancel it so that we get the original back. So that means we have to root it and square it. G square plus f square minus c square. And this is exactly how this equation compares to the equation of the circle which we derived previously. So here the center is at minus g minus f, and radius is square root of g square plus f square minus c. By the way, this is called the standard or general form, and here remember it is a quadratic equation in both x and y, and coefficients of x square and y square, not plus x square and y square is 1. Now if it is not, what do you do? If the coefficient is not 1, divide the entire equation by, or every term on both left and right by the coefficient, so that you get 1. Okay, and there is no term with xy. It is a quadratic equation in x and y, x square and y square, and the coefficient is 1 of x square and y square. Now, the radius is square root of g square plus f square minus c. Now, there are three possibilities. One is if g square plus f square minus c is greater than 0, then we will get a real radius. If g square plus f square minus c is less than 0, then we will get a imaginary or virtual circle. So virtual radius. And the third case is g square plus f square minus c is equal to 0, which means it is going to be a point circle or 0 radius, or we can say Instead of saying radius, we can say circle, imaginary or virtual circle. Now, apart from this, if the center of circle is on x-axis, you have this, then center, right? Center is on the x-axis, that means y equal to 0, which means minus f is equal to 0, which means f equal to 0. So therefore the equation would become x square plus y square plus 2gx plus c equal to 0. Now similarly, if center of the circle is on the y-axis, then x equal to 0, which implies minus g equal to 0, which implies g is equal to 0. So therefore the equation would become x square plus y square plus 2fy plus c equal to 0. Now, another situation is when the circle is passing through origin. Yes. So you have something like this. It is passing through origin. So here c would be equal to 0. So therefore the equation would become x square plus y square plus 2gx plus 2fy. C will disappear. Now if we look at the equation of the circle, x square plus y square plus 2gx plus 2fy plus c equal to 0. There are three variables, three unknowns to g, f and c. Three unknowns. So therefore we need three conditions to determine the equation. So that's it for today. Bye.